Hey guys, so we're going to go through the transformations of graphs notes from the top. So starting out with reflections. When you have a negative in front of your f of x, in front of your function, that is going to be shown in the graph as a reflection over the x-axis. We're going to be seeing this one primarily in our notes for this year. F inside of the function, so within the input, that's a reflection over the y-axis. You're not going to worry about that. It's just put on the paper just so you're familiar and you're aware that it does exist. But again, this is the one that we'll be seeing this year. Translations, we should be very familiar with translations because we did graphing. We've already seen as phase shifts and vertical shifts. So when you're adding or subtracting something outside of the function or outside of your parentheses, or you'll see it as in outside of the absolute value or outside of the square root, that is indicated with an up or down movement. So plus C is an up movement of C units, minus is a movement down of however many units for that. When you're within the parentheses, that would be connected to what we would think of as our phase shift, our left and our right movements. So when you have plus C on the inside, it's kind of counterintuitive, but when you're having plus C, you're moving to the left. When you have minus C, you're moving to the right. So again, translations we should be familiar with. This should not be something that will give us a lot of trouble. Dilations is going to seem like a complex concept, but it's actually not that bad. It's when we have a number or a coefficient outside of our function. If that number is less than 1, the graph is going to sink closer to the y-axis. And I'll show you what that looks like in example B. 1/2 is less than 1. We'll see the sinking happening here. If you're multiplying by a number greater than 1, like we'll be doing in C, or multiplying by 3, the graph is going to stretch away from the x-axis. And it's always going to stretch or sink at the rate of the coefficient out front. And again, I'll show you what that looks like. So first off, we want to maybe describe in words what transformations are happening based on the function. Then we want to sketch in the parent graph. I'll do that in a dotted line. And then you want your final answer to be the new transformed graph based on the reflections, translations, and dilations that we're going to see. So starting out here, we have the parent graph of the absolute value of x. And we have just that plus 2. Plus 2, that's a translation of up. So we're going move up 2. So up 2 units. So that's the description of as what is going to happen. I'm going to sketch out my my parent graph with a dotted line. So the absolute value, we know, has this basic shape. And again, you guys need to know the parent functions. You need to know the basic shape of the parent function. So from 1, it's 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. -1, the absolute value of -1 is 1, -2 is 2, and so on. So I'm going to fill this in with my dotted line. From this, the only thing that's changing is that I'm moving up 2 units. So if I have 0, 0, I now have 0, 2. So from this point at 1, 1, I move up 2 spaces, up 2 spaces. So each of these points has moved up 2, and this is my final graph in red. All right, for number B, or letter B, we've got 0.5x. This is a number being multiplied on the outside as a coefficient out front. Less than 1, so this is going to, in words, we'll say, sinks closer to the x-axis. So again, I'm going to just quickly sketch out my parent function, what that's going to look like. And then I'm going to sink closer to the x-axis at a rate of 1/2. So if I was at 1, 1, my new value is going to be 1, 1/2. If I was at 2, 2, my new value would be 2, 1. 3, 3, I would be at 3, 1.5. 4, 4, 4, 2. So instead of going, I basically cut each point in half away. So I've sunken closer to the x-axis, and I'm going to do the same thing on the other side. I don't need to plot all of my points, just enough to get that straight line drawn in. So what's happened here now, and I know that's not a perfectly straight line, but that's okay, is my function, my graph, has kind of looks, it's like sunken closer to the to the x-axis here. It's a little bit closer. It's not as far as it used to be. So when the number is larger than 1, we can imagine that instead of being, so if we think about this is the parent, I've sunken closer when the number is less than 1. If this is my parent, I'm going to go further away. We can think of it as getting smaller. So here we're going to stretch away from the x-axis for this one because I'm multiplying by 3, which is a number greater than 1. So this stretches away from the x-axis. Okay. So with my basic dotted line for my parent function, I'm going to stretch away from it. So if I was at 1, 1, now I'm at 1, 3. If I was at negative 1, 1, now I'm at negative 1, 3. Okay, and so I don't need to plot the rest of these because I would have 2, 2. I would be at 2, 6 up here. I could plot that. That is still on the graph. So instead of 2, 2, I'm now at 2, 6. Because I multiply that 2 by that 3, that gets me up to 6. Negative 2, 6 as well. And that's all that I need to plot the translated, reflected, and dilated graph. All right, D, we've got a couple things going on with D. We have a negative out front. So that negative out front means we are reflected across the x-axis. So reflected over x-axis. That -1 and that -3. We've got -1 inside the absolute